Hello everyone, so today we start using Python to use our database. So far we learned how to describe our database requirements in the ER diagram, and then using SQLite we are able to create this database, create the tables in that database. And then we are also able to implement some queries to get different views of that database. So with the queries, what we would like to do is to retrieve the data in different views. And we also relate different tables. We can also insert data or update data. Then we would like to create some program to do these things for us. So we would like to use Python to implement a system to interact with our database, but we would like to do it in a way that it will be easier for the users to do the tasks. So for example, the average user does not know how to write a complicated SQL query, but we can write such queries and give some parameters to the user. The user could change those parameters to interact with the database. So with this task, we are going to today start using importing an SQLite database to Python. We are going to execute some queries, get some results, print those results using the command line view. Then in the later labs, we are going to start using the graphical user interface. So if you go to the lab homepage, the slides are there. And to do that, you can use any Python distribution. But if it is not installed on your computers, we also have a little tutorial that helps you to install one version. And in here, I think the easiest way to install it is through the Anaconda distribution. So you can download it from here. The individual version is free to use, and it automatically installs anything that you might need onto the computer very easily. The Python, so you need to have Python on your computers, but it doesn't have to be this version. So it can be any Python. I guess you already took some classes for Python. If you use something on your computer, that's fine, you can go with it. But in this tutorial, I'm going to use Jupyter Notebook. So if you haven't used the Jupyter Notebook, it's very useful actually, you are going to see. But for example, I guess some of you use Spider. That's okay, you can use those. So if you want to install the Anaconda distribution of Python, plus if you would like to use the Jupyter Notebook, so these slides are covering that topic. So you just go to the website, the individual edition is the free one. You download the version that's compatible with your operating system. Then after the download finishes, you just follow the steps of the installation process, and the default options are okay. At the last step, it asks whether you would like to bookmark some pages for information. You can uncheck those, so those are not really needed. And when you install it, it is going to be, so let me get out of these slides. So you can go to the start menu and type Anaconda Navigator, or you can find the Anaconda from the start menu, and it has some components in it. So for example, to access everything, you can just run Anaconda Navigator. So it includes all the applications that are in it. So I'm going to open Anaconda Navigator. You can have different environments in it. One environment is already installed in the first setup, and these are the applications in there. Some of them are already installed, so for them it says launch, but for some of them, if I would like to use them, I can install them easily. So for example, we have the command line prompt. So if you open that, you can use the pip installation from here. For example, if you need to install some new libraries, for example, from here you can type Python to start Python. You can have like calculations and get the results. So this is the command line version. We also have this Jupyter notebook. So I'm going to launch the Jupyter notebook. It comes installed, but if it is not installed, you can also install it. For example, sometimes you may need to create different environments for different tasks. In those cases, you just install the applications that you need to use. So in your default internet browser, it opens this Jupyter homepage, and you have one root directory for your Python application, and this is currently in that root directory. So if I just go to that user directory, which is in under the users on Windows, so these are just the files in this folder, and in here we can open Jupyter Notebook files. They have the IPYNB extension. You can also create such files, and you can browse the files. So I'm going to go through this creation process. At top I have this new button, and I can create a Python 3 notebook file. It opens as a new tab, but I can at any time come back to the home page of Jupyter Notebook. So this is going to be my Jupyter Notebook, and in here we have multiple cells. So I guess some of you didn't have any experience with Jupyter Notebooks. So on the backend we are running a Python kernel. We can have multiple cells of Python code. For example, in here I can say x equals 5, y equals 9 maybe. Let's say z equals x plus y. Then let's say print z. So I can run these individual cells, and the output of those individual cells will be printed beneath them. So for example, if I come back here, if I run it again, it will run and show me the results, and on the left part it increments the number as I run some cells. And the good thing about it is that, so for example, I can also have like other cells that contain some code, but the good thing is that the kernel of the Python is going to be the same for all of these cells. So what does it mean? That means if I, for example, in here define some function, for example, let's have x and y as the parameter. So this is going to be the description of my function, and in here, oh, that was not y, so I just corrected it. So my function is going to get two values, sum them up, and print the result. So given that I first run this cell, so I'm going to run that cell, it doesn't have an output because it just defines that function. But then I can use that function in some other cells. For example, in here I can use this function with different parameters. So this is going to also include the C here. And I can have multiple calls to the same function with, for example, different parameters. In Jupyter Notebook, we can also have some markup cells. So markup cells are there to give some information to you. So under cell, while one of them is selected, I'm going through cell type and I'm going to choose markdown, which makes it a markdown cell. So you can have some notes here, you can have some figures, etc. If you run, so that becomes some notation, some description there. So in the lab files, we are going to, so for lab 4, we have a Jupyter Notebook file. We are soon gonna look at that, but I'm going to give the Jupyter Notebook files, And the good thing is that in there I can have some descriptions, so I can have some markdown cells and I can have some code cells, and you can go and run those code cells and see the results. You can like work on them, change some parameters, etc. In here, when you are in one of the cells, control enter from the keyboard runs that cell, so you can use that hotkey as well. But if you, for example, restart this kernel, so from kernel I have the option to restart the kernel. If I restart the kernel, then it means that my function is not yet defined. So I can directly go to cell 2, for example here, try to run it, but it is going to give me an error saying my func is not defined. So wanting to be careful, if there are some functions, there could be dependencies between different cells. So I need to first run this first cell to be able to use the function. So this is like one thing about the Jupyter Notebook files to be careful about. But you have also the option to, for example, when you are restarting, you can say restart and run all. Then it is going to run all the cells in order. So if some dependencies exist, then this is going to cause you no problems. So I can also save this notebook file. For example, let's call it lab for example X something, because I guess I have some example files already. So I can give a name to this file. If I go back to my home page, then I will see that from this green symbol, it means that it is currently running. I also see this information on this right side. But if I were to close this notebook file, I can open it back again from my home page. I can move it to some other folder, etc. And the outputs, the last outputs are also staying there. So I guess after running that, I forgot to save it, but you can like use Ctrl S, or from the file you have the option to save your Jupyter Notebook file, and it also saves the last output. So whenever you open it back again, you will see the outputs there. So that's about it for saving, loading files. And this file, of course, is in our working directory. So if you need to copy it, you can also go to that directory. But one better option is, since this is kind of designed like a web interface, in here to interact with your root directory, you can upload files or you can download files from here. So in this case, let's say I would like to have some backup of this new Jupyter Notebook file, and I can choose that file, come to this top part, and in here I guess actually it should not be running, I guess, to copy it in a better way. So I'm just going to stop that file. So I'm going to close this for now, but you can come to here. So this was our file, and download that file. So if you choose download, then it is going to use your internet browser, and it is going to download this file to your download directory, so you can have some backups of your files. And to include some new file in your working directory, again, one option is to find your working directory, and from this folder you can directly copy and paste your files. But one other option is to upload that file. So if I choose upload from here, then, for example, from any folder, I can copy my files to this working directory. And in this example, we are actually going to do that. But first, I'm going to show how we can open a new database file, open a SQLite database file using code. So to do that, we are going to use SQLite 3 library. So it is included with Python versions, I guess, later than 2.7. So most likely your Python version will include SQLite 3 library by itself. If not, you need to use a more recent version of Python. But this is an example code here. In the PDF files, in the slides, I put the code as a text box, but if you try to copy it, there is some slight problems. So let me actually show it. So I'm back to the file that we were working on. If you try to copy and paste from there, sometimes for some of the symbols it doesn't paste well. So because of that, I'm actually going to get it from this original version. But you can, if you need, look and write those code. And this is actually just one startup code. The main part that we are going to look is included as a Jupyter notebook file, and also there is this version with py extension. I'm going to talk about it, but the both versions of the main part that we are going to discuss is there. So to import SQLit3 library, we say import SQLit3, and in your Python version, if you want to make sure that it is working, you can try to import it. If it doesn't give any errors, it means that your Python version is compatible with it. And this is some API, and actually there are some really helpful functions to connect to database files, to execute SQL codes in those database files. So we are going to use the connect function to import a database or to create a database. So the same connect function tries to find this file on your working directory. So that's the home page if I have my code on this page, or if it is in some folder, if my IPYMB file is in some folder, then it is going to search in that folder. If there is such file, it is going to connect to that database. So this DB extension is what we can create with SQLit Studio, for example. We can create our database using the Studio, then we can import that database here. So it imports, or if it doesn't exist, it exists, it is going to create that. Then we keep a cursor to this connection, and in any stage to interact with this database, we are going to use this cursor variable. So in this instance, there is no new db.db file. It is going to create that database file, and it will be connected to that database file, and we are keeping some connection, some cursor to that database file. Actually, this was not the version that I wanted, so I'm going to get the code from a different one. Okay. So this is going to be my code in this new Python file that I'm working on. And remember, to create tables, we have create table SQL queries. Using this cursor, I can execute any SQL query. So one SQL query could be to create the table. So I'm creating a new user table with ID, surname, and name attributes. And the parameter of this execute function is going to be a single string in this case. But there are multiple different ways of representing a string in Python. For example, one way is to include 3 single quotation marks. Then we can have multiple lines of the string, and to end the string, I again include these 3 quotation marks. So anything in between these marks is going to be a part of my string. Then what we are gonna do is to using the same function execute insertion queries. So we would like to insert some new users. For example, in SQLit Studio, I can directly write such query, and in this case I'm passing this string, the query as a string to the execute function to execute this query in the database that I'm connected to. So we are inserting a bunch of users. One important thing is that if we are updating something, if we are inserting something, we need to commit those changes. Otherwise, it will not be saved into our database. While we are connected, we are able to see those new results, but if we want to save them into the database file so that in some other time when we connect to that database, if we would like to see those changes, we need to commit our changes. So that's one important thing. Again, this part is same as before. We are using this cursor to execute SQL queries, but with one difference. This time our query is going to project something. So it's a selection query. It is going to return a set of results. And we can use a for loop to go through those set of results. And we can print each row in the results of those queries. So right now let's run this query. So Control Enter. The problem here, it says table user already exists. So the problem is, in the other section I already run this code. Therefore, there is already an example DB in my folder, and in there is already a user table in that database. So let me just go to my folder, and I would like to delete this example DB. So okay, only the first version. Okay, the other was a copy of the connection. So I'm back to here. I'm going to run this. Actually, I guess I need to interrupt this one. Sorry about that. The database that we are looking is called example DB. So now I can delete it because okay, let me just, for now, I guess in one of them we might be connected to. I'm going to just change the name of this database. So instead of example.db, we are working on the version with the 2 extension. So right now we just run the query. It created the database, it created a new table, and it inserted these users. We committed the changes, then we are printing the results of our selection. Then at the end we need to close the connection to that database. Otherwise, if there is some limit on the users that you can can interact with this database, then like up to some connections it might be allowed, but more than some connections might not be allowed to the same database from the same computer, etc. So that's why we are closing the connection at the end. So in this new cell, let me connect this database again. So in the example files, in the love files, I'm going to include the imports that we need for that specific cell. So that, for example, if you would like to just run one individual cell from this whole example, it will be enough to just go there and run it. Otherwise, we know that we are running the same kernel. We can include this. So I'm going to insert a new cell above here. In the normal way, I would import the library in one cell, and then in the later cells, I don't really need to import it, given that this cell was run before. But if I'm going to just go to one of these cells to keep them individual, I'm also importing the libraries, the required libraries, multiple times. So if you wonder why they are there, that's why. That's the result. That's the cause of it. So okay, we are connecting to this database with this code. I might want to just print the results. So in here I can print the results. Let's say this time the company. Oh, sorry, there is no company table yet there. Okay, I'm still showing all the users, and at the end I'm going to close the connection to this database, and here is my results. And let's say I would like to add some other cell here. So if you choose the cell from this left area, you can use the A and B hotkeys to insert a new cell above or below the cell that you have. So I'm going to get these three, and in here I would like to execute some query, but that query I would like to insert some new user. So in here I'm going to insert into the user table, and the values that I would like to insert are going to be 4, and then I need the name of the user, which is going to be a string value, or actually there is already then here. So we are actually seeing that to be able to include some string in single quotations in my query string, I need to have, or a better way to do it is to just use the double quotation marks. So anything in between these double quotation marks is going to be a string, and I can use single quotations within that string. So in the SQL query, to say that something is going to include text, for example, the name of the user is text, we need to include these single quotation marks. So if I use the double quotation, then it is going to be fine here. So let's just make up some user. At the end, what I need to do is to close the connection, not the cursor. So I'm going to close the connection at the end. But in between, let's say, I would like to also print all the existing users here without any commits. So I'm going to run this query. We have some mistake here, and that mistake is, let's check. So it says near 4 syntax error, and if we come back to here, we need to say that, okay, these are the values that we would like to insert. So while it is running, after the insertion, it can show this new user, but if I'm back into the cell below, if I try to run and execute this selection query, then the new user is not there. So what I'm trying to show is here, after we insert, after the insertion, while we have the connection on, that changes will be shown in the database. So for example, if I'm experimenting on some database, let's say for the project I have lots of users in my database, I would like to experiment, then in those cases you may not commit, but you are going to see the changes in the database still until you close that database. But if you close the connection, then those insertions or updates will be reverted. So unless you commit, for example, in here, to commit the changes, what I need to say is, for this connection, I'm going to call the commit function. Then in here, okay, I see this new user, and in the other cell I can also see the new user. And one more thing, if I try to execute the code above again, then it's going to give me an error. So it says unique constraint failed for this user ID, because for user ID it should be unique. It is the primary key of this table. I cannot insert another user that has the same primary key. So that's the problem with that one. So let's say I'm connected to a database from my Python code, but I really don't know what's in that database. So to check the tables, or to check the information, we can use this special query already. Although we do not create this SQLite master table directly, it automatically creates such table when we have an SQLite database. So in this case, we would like to get some information from some existing database, but we need to import that existing database first. So in this case, we would like to use the SQLite database from lab 3. So it is already included on the lab website. So I'm going to download that. I actually already downloaded it before. It's here. I would like to include it in my working directory. So in here, there is no lab3.db yet. So to include it, I'm going to choose the upload option. And from here, I locate the lab3.db. I choose OK. And in here, I can rename it as well. But I'm going to choose upload. So this is not about some internet usage. This is just how the Jupyter Notebook is designed. It is using the internet browser. So I can now see my lab3db in the folder. So if I come back to this code and if I run it, then it is going to display some information, and these are actually the create table definitions for all the tables in this database file. So remember, in the last lab we had users, companies, and the partner of relationship in between those tables to relate one user to one company. And the create table statements for each of these tables are there. So if it says table, it is a table. There are also some automatically created indexes for the each of these tables. But I can get information using Python, although if I don't know anything about this database file. One thing to be careful, if this file is not in my folder, then it is going to create that file. And since we just create that file, it is going to display nothing. For example, there is no lab1.db in that folder. If I try to run it, it's not going to give any errors because it's going to create that database and it's going to try to show the tables in that database. We don't have any tables, so it's not going to show up anything. Or for example, if we were to look at example2.db, we would see that, okay, while creating this table, we actually use this statement. So actually, it even includes this tab or new lines in our SQL query. So for example, in this database, in this existing database from last lab, I can execute a more complicated, let's say, query. So I can join these three tables and at the same time have some condition on the credits. And for each row that I get from this result sets, I can print that row as it is. So these are the results. So I'm on one side showing the name of that user, and on the other side we have the company name for this user's partner company, and we also show the credit for that user, and for these users we should have credit larger than 400. So now I'm going to go through this lab4 Jupyter Notebook file. So once you download it, you need to include it in your working directory. So I'm going out of there. So to include some new file to my working directory through Jupyter Notebook, I can click upload, and then I need to choose my IPYNB file, and I'm going to import it here. And then to run it, I just need to click on that file. And in here we are going to have different examples that you might need. So for some of the cells we have, for example, calculations about dates, how to do some specific tasks. So we are going to go through each of these examples. So for example, this is some markdown cell. It gives information. If you want to edit it, you can just double click on it. But once you run that cell, which is a markdown cell, it shows up as an information. And since this is a markup language, you can color your font, change the size of it, etc. You can include figures. You can do many things with it, but we are just using the simple text version for now. So with this first example, We are always, remember, using the SQLite3 library to interact with our SQLite database file using Python. So SQLite3 library is also available in some other languages, but we are using the Python version. We connect to this existing database file. We keep a cursor to that connection. And in this example, we are getting all the companies, so a very basic query, selecting everything from one table. And for each row in that result set, we are printing that row before inserting some new company. And in here, this is the code to insert some new company. And then after insertion, we again print the companies, then close the connection. The thing is, we do not commit our changes. So remember, the Python, this notebook files also include the outputs, but to get the last output, I should run it. So this is the output that I got earlier. So in your own computer, if you download it, you will be seeing the output from my execution. To run it again, you need to choose that cell and run it. But for this example, it's going to display the same thing, because before insertion we have a bunch of companies. After insertion we have one more company. But the thing is, we do not commit our changes, so therefore every time I run this query I will get the same results. So before insertion there is no company with ID 11. After insertion there is this new companies, but since we do not commit our changes, it is not saved into our database file. So one thing we should be careful is that to keep the information, we need to commit our changes. For example, in this second cell, if I run the same selection query, then that new company is not there. So in here, we are going to do some insertions, and then we are going to commit our changes. And to execute some query, remember, we can represent our query string in different ways. So one way is to use 3 single quotation marks, and then I can have different lines of SQL string, and it is going to end with another 3 single quotation marks. I can use the double quotation mark, then on the same line. So if I were to go to a different line here, then these are not treated as strings anymore. So the first half is a string, but this becomes some weird thing. So with the double quotation, the whole line until I get another double quotation becomes a string. One thing that we would like to do often is going to be replace some values or have some parameters that I can pass to my SQL code. So on one hand I have my SQL string, and on the other hand I have some Python variables, and I would like to use those Python variables in my SQL query. The way to do that is to put question marks into the SQL query. So in my SQL string I'm going to put some question mark symbol, and to the execute function, so this is the execute function. The first thing is the string. The second thing is going to be the tuple that is going to replace my question marks. So let me just undo that. So it has to be a tuple. So we are going to look at that. But to have a tuple object, or let's say to have a tuple, to have a Python tuple, I need to include the parentheses, and to say that it can be multiple things as well, I need to put the comma there, but I don't have any other elements. So normally a tuple is used to have multiple things in just one variable, but in this case a tuple is required. So even if I have one question mark here, I need to have a tuple. It cannot be just directly the integer. So then once we run it, it is going to look up the SQL string. For the first question mark, it is going to replace it with the first value that it encounters in the tuple. And since I just have one question mark, That's going to be it. So for example, I can define this tuple on a different line, and in my SQL query, for these values, for insertion, I'm going to include three question marks. Then I'm going to pass this tuple. So I could have also just directly write this parameter, the tuple, as the second parameter of the execute function. That's also possible, but to not to have some crowded code, we make this initialization on a different line, and then we just use this execute function. It is also possible to have multiple tuples. So in this case, I have a list of tuples. So this is one tuple, this is another tuple, I have comma in between them, and this is given as a list. There is this execute many function, and with the execute many function, I can give a list of tuples to the query, and they are going to replace the question marks in my SQL query. So these are the new company values. It is going to execute them one by one. So it is going to be the first tuple first. It is going to replace these question marks with the, for example, with the first one first, and then this is a string, so it is going to replace it with the string. So this is an integer, it is going to replace it with this integer. It is going to run this query, and then it is going to be doing the same thing for the second element of this list. And at the end, we commit these changes. So if I run this query once, so I just run it, then on this other cell where I print all the existing companies, they will appear there. So these are my companies. One thing about insertion queries, if I were to try executing the same query again, it is going to fail the unique constraint because I did not change the primary keys in these values. So I cannot insert the same primary key again into the same database. So in here, we are going to interact with the user. So one simple way is to get some argument from the user from keyboard. So using the input function, in here we give a message to the user. We are saying enter the limit for the credits, and then for this value, we are holding this value in this limit variable. We are going to print this limit variable here as well to give some information to the user, and this ID, name, surname, credits are going to be the columns that we are actually showing to the user. And then my query is going to be this one. So in here I have my query. It is a string, but since I did not really need to use single quotations within my string, I can also hold my string in between these single quotation marks. So there are actually like different ways of doing it. I can use the double quotation symbols here as well. Then if I were to have some parameter which is a string directly, I could have include those ones. But if I'm using the single quotations, then if I in between my string use single quotations again, then it's going to be a problem. I need to append those strings, etc. But in this case, we have this question mark at the end, and it is going to be replaced by our limits. So then we are printing all these rows. So if I were to run this code, then it asks the credits for from the command line. Here, let's say 300. If I hit enter key, then it's going to print the results. For these results, the credit is higher than or equal to 300. So this is one way of interacting with the user. And you can also consider, for example, we posted our, so let me actually get that. We posted our functional requirements for the project. So this is more about the implementation stage 2 and the final demo, but you may start thinking about such tasks. For example, list all tributes that are assigned to this mentor, or for example, list existing addresses of this customer or list crime scenes that this field officer is assigned to. And in most cases, you first log in as some kind of user, and we are going to have a login example in the next lab. But for now, you might start thinking about how to interact with the user using such tools. And in the next labs, we are actually going to start doing this with a graphical user interface. So right now we are just using the command line. We are getting the input from the keyboard. We are outputting the results with printing. But you might start thinking or considering those functional requirements as well. So in this example, we are going to work with strings or dates. So for dates, we need to have them as some specific strings in a specific format. So year, month, and day. And I need dash symbols in between those numbers. So for example, we can get some input from the user, but the user should follow this format. Then we are going to use these date limits as a tuple. So remember, if I would like to replace question marks in my SQL query, I need to have a tuple. So we give some information to the user, but then in our query, so that's going to be the more interesting part, in our SQL query, we include two question marks, and this date limits tuple is going to be used for replacing those question marks. So if I run this cell, then it's going to ask for me to enter a starting date. Let's write some date here, and for the ending date, let's write another one here, and it is going to display the users that are born in between these starting and ending dates. So for example, in your project, you might need to include such functionality as well. So with date objects, so with integers, we can just directly get them from user. For strings, again, the same thing. But with dates, sometimes we may need to find the today's date, or we may need to do some calculations about date objects. So to do that, we can use the datetime library. So in there, we have this today function, which gives the today's dates. Then this string format is used to make this date in the correct form. So in our in SQLite, we need to have the year and the month and then the day. We need these dash symbols. So it is going to format this date object as a string in the correct form. And again, this is going to put it as a tuple, because we can we can only replace the question marks with tuples. We just connect to the database and execute a new query. So we are inserting some new user, and for this new user, we would like to insert the date of birth using today's date. For example, maybe this is used when a person borns, and we are going to insert it with this today's date. So I'm going to run this query. It doesn't output anything since we do not have any print functions there. But we can, in some other cell, since we committed the changes, we can go to some other cell and we can just print all the users. So I'm going to execute this query, and you're going to see that as this new user, it's written today's date, so in the correct format. Sometimes we may need to do some calculations about day-related tasks. So in here we have such code. So in here we do not connect to the database. We don't have the import SQLite 3 code here. We are not using the database, but this is for showing how to do some day-related tasks. For example, there is this time delta function to describe a difference in terms of days. And for example, I can find today's date, and then I can subtract 50 days from that, and putting it to the correct form, I can show what day it was when it was 50 days earlier, for example. Now let's give a 10 minutes break and then we will continue. If you have any questions, you can ask. Otherwise, let's give a 10 minutes break. Any questions, problems before we start? So with integers and strings, we can have some interaction, and for dates we might need to use the datetime library, because sometimes we would like to find the today's date or to calculate the difference in between different two dates, since there are like some special conditions for dates. We can use the functions. For example, in here we were getting the today's date and then converting it to a string in the correct form. And we can also use the time delta function to describe a difference of dates or day. In terms of days, we can describe a difference. And for example, to find the difference in terms of days between two different dates, we can create two datetime objects here. So in the functions parameters, the first one is going to be the year, followed by month, and followed by the day. We can find the difference, and we can print the difference in terms of days. For example, there is also option to find the difference in terms of seconds, etc. Because this datetime object also covers the current time. So that's why in some parts we need to convert it to the correct formats, or we might need to get some related information. And sometimes you may need to get random values. For example, to get a random date, you can use this random library. In there we have this randint function. It takes one or two parameters. In the two parameter version, you can define the range. So for example, in here we are getting a random integer in between 1 and 12, and 1 and 12 are also included in this case. And we can use this random integers to create a datetime object. So for example, in here I can run this function. It shows today's date, the first print that we had. So 50 days earlier it was this date. For example, in here it also considers the year and the month to make the day calculations. And between these two dates that we entered directly, there is this many days of difference, for example. And we are creating a new datetime object using random parameters. In here, for example, if the months and days do not match, it might give you an error. That's why we said the upper bound for the days is going to be 27, because for some months it will cause error. But if you really need to cover all the possible random dates, you can like have some if and else statements to control the boundaries for days. But whenever I run this cell, the random date is going to change. So for example, in some tasks you might need such thing. And since this is a string, so I can use it in my SQL query as I want. So it could be used as an insertion value or some var condition, etc. So in this part we are going to look at some error messages that we might get, because we can have three different problems. So the first one, a Python syntax error. We can have a syntax error in our SQL query, or we can get some errors about the constraints. For example, if we try to insert a user with the same primary key, it is going to not be a syntax error. It's going to be a failed constraint, for example. So the first one, this one, in here we are writing use instead of saying user. So there is no use table. It should have been user, but error says no such table in this case. So if we are to write the attribute name wrong, for example, in here we would like to project the name and surname of the users, but in here we had a typo for the name attribute, then it's going to say there is no such column with this value. So it gives some useful error messages. So for example, if we try to insert a new data, but if that's conflicting with the primary key of the existing values, let me run this cell. So for example, we are trying to insert a company with CID 1, but there is already such a company. In this case, it's going to fail the unique constraint for this CID attribute in the company table. And while using parameters or while inserting something, we can give different numbers or incorrect number of parameters. So for example, in here in the company table we have 3 different columns for the ID, for the name of the company and the monthly payment of that company. And in here, while creating a new company, we did not give the company name information. So in this case it is going to say that the table company has 3 columns, but you are giving different numbers of columns. So even if we give like more columns, then this is going to again complain that in the company table there are 3 columns. If you would like to insert using this notation, then you need to give all of them. But there is, remember, one other way to insert new companies. In that case, next to the table's name, I can write the attributes and the order of the attributes. For example, in here I can say this is first one is going to be the CID, and the second one is going to be the monthly payments. I would like to insert a new entry, but I'm only giving these 2 attributes, and if it is enough, you should insert it. But then the error message is going to change. It's going to say not null constraint failed for this company table, because in the company table company name was required. So I need to have some value of it if I would like to try or if I would like to insert some new entry. So in the second cell we are using a different notation. This time we are trying to insert the null value directly. So instead of saying okay, I just pass these attributes, we are saying okay, I'm going to give all the attributes, but for the company name it's going to be null. Again, this is going to give you the same error, because for that attribute, if I would like to create a new entry, I need to give information for that column. Sometimes we might forget, for example, the parentheses, and in here we forgot the parentheses within the query string. So anything included in these double quotation marks is my query string, and if I were to copy this query and go to SQL Studio, for example, and if I try to run this query, it is going to give me the same error. It's going to complain that this query is not finished. In here it says incomplete inputs, because I need to have some closing parentheses at the end of my string. But again, even if I correct it, this query was failing the null constraint, so therefore it's not going to insert it. To be able to insert it, I need to give the company name. So the company name was a string. I'm using the single quotations, and I need to give some company name. Then I can run this query, and it's committed. It saved the new data, but if I try to run it again, then I cannot insert the same primary key again. It's going to say unique constraint failed. And one other example, in here we have a syntax error for the Python. So for this Python function executes, I'm missing the last parenthesis. My SQL query is complete, but in this case it's going to say invalid syntax. So this is a syntax error for Python. I need to include this last parenthesis, but then this was trying to insert the null value. And remember, we replace the question marks using tuples, and if you are not giving a tuple, then it's going to give an error for this function. So this function expects just a string, so it can get just one string, or if you are using question marks within that string, it also needs a tuple here. So I have my string and I have an integer which doesn't satisfy the condition of this function. So this time it says parameters are of unsupported type. So you are expected to write a tuple here. So it's, even if it is just one value, you need to have a tuple for it. So to make it a tuple, I include the parentheses and the comma to say that, okay, this is going to be a tuple. Then if I run it, then it's going to insert it. So now we would like to have some program, and in this program we would like to support multiple things. So for example, we print the menu to the user chooses some option, and we do interact with the database accordingly. So in here, let me first run it to show how it functions. So I show the menu to the user enters some choice. For example, let's start with 1, show all users. It's going to print all the users in the database, and then it shows the menu back again, and we can enter our choice again. So for example, let's write 2. It is going to list all the companies. We can choose the option 3. It says show users with credit greater than a limit. So I'm choosing 3, and then it asks for the limits, and then I can write this limit, for example, some value, and it's going to display only such users. And in such cases, the users might also write some weird values, for example 29, and it is also saying that the choice should be in the range. For example, in such cases you might need to be careful about such things. And if I would like to exit, I just put the input 4. Now let's look at the code. So in here I'm keeping the user's choice in a variable, and I have a while loop to show the menu, get the input of the user, and do the tasks repeatedly until my choice is equal to 4. So if the choice is 4, we are going to exit. But for any other choice number, we are going to first print the menu. So, and since choice is initialized to 1, we enter this loop in the first part. We show the menu, and we get an input from the user. One thing to be careful, anything we get with the input function is going to be a string. And if I would like to compare this value, for example, with if and else conditions, I'm going to compare this value. I'm going to look up this choice number. It should be an integer. Or one other thing, if I don't want to use an integer here, I'm going to compare these values to strings. So that's something to choose from. But in this case, we decided to use integer values. So we get the input from the user. It may not be converted to an integer as well. So that's one risk. So I'm going to run it now. So the user might write some letter there, and with the int function, I'm not able to convert it to an integer directly. So if we were to use like command line input, then we might need to be careful about such things. But in the next labs, we are going to start using graphical user interfaces, and there you can have more strict control on what user is writing, for example. So after printing the menu, then we get the user's choice as an integer, and according to the choice of the user, we are going to do different tasks. So for each of these different choices, we execute different queries, but we print the results of those queries. So printing is the same, but what changes is the query that we execute. And if the choice is number 3, we also need to get the limit as an input from the user. In such cases, for this example, the code is not that long. So what we do for choice 1 is just 2 lines. But in the project, there could be like lots of lines that we do for one choice, one user choice, or we might have like multiple windows. So from a menu window, we can go into a specific window where we show to the users. And to have the functionality in an easier way, you can implement functions. For example, in here I can say, okay, define a function for choice 1, and in that function what I'm going to do is to do these two rows, for example. But then in here, if the user's choice is 1, I can directly call this function. So it's not going to change the functionality from the user's point of view, but in the code it's going to make your life easier. For example, in the group work, some members could be working on specific functions, and in that function maybe we are going to open up a new window, put some items there, run some query, get some results, display some results to the user, and one button there could call some insertion query, for example. And if you keep it in a function, then it will be easier to manage. Once you combine everything, you can get the different functions together, and from this main menu, for example, according to what we are doing, which button is selected, we can just directly call those functions. So right now we are not using any graphical user interface, but in the upcoming labs we will do that. And even when we are using the interface, the graphical user interface, such things will help. So in here, if the choice is 4, we print goodbye, and since the choice becomes 4, then we exit this while loop and commit our changes and close. Actually in here, since we are not making any insertions or updates, we really don't need to commit our changes. But maybe in some other time we can include any additional menu items to insert some users. So that's why we automatically wrote commit there. So in this new one, we are going to get individual elements from a row. So far, while we were printing the result set, so we run a query, we get a result set, a list of rows, we just print those rows as it is. But we can also get individual elements in different indexes in those rows. So we also look at different ways of getting the results. So for example, so let me come to here first. So one way is to execute the query. It returns a result set, and it's a list of results, and I can iterate over that list of results, and I'm calling a row. So each item in this list is called a row, and with this for loop I'm just directly printing those rows. But there is also one other way of getting values from our execution, from the selection queries. I can just say, okay, execute this query using this cursor.execute. It executes that query, but I'm not getting the list of results yet. I can use the fetch1 function. It gets the first row only. So I'm just getting one row, and in here I'm going to first print that row. So let me actually run this query and see that results. So I'm just printing one row here. I execute the query. It is going to be for the first entry in that query. So we are printing the users, and it is going to fetch the result or the row for that user. We just printed that user. We can look at the length of attributes. So in here we are projecting all the columns. So how many columns are there? You can find the length of R. You can directly refer to individual elements. So for example, in the value, in here in the index 2, I'm going to display the result directly. So for example, if I come back to the output, so we just displayed the whole row. The attribute count for this row is 7. So 1, 2, 3, 4, 5, 6, 7. We have 7 attributes, but the last one, the city information, is null for this user. But then we can get the values from individual indexes directly using the square brackets. So for example, index 0, 1, and 2. Index 2, we have the name as a string, but we just printed that. So if I pass a string parameter to the print function, it doesn't include these single quotation marks. And if it's a number, then I can directly work on that number. So for example, we can get the credits for this user, for this row, from the index 3. We can directly multiply it with 2. So in here I'm trying to say that what we get from individual elements have their data types already. So I don't need to really convert it to a different date or a different, sorry, I don't need to convert it to a different type. So the name of the user is a string. I get a string from R2. The credit is a number. So if I write R3, it is going to give me the number so that I can directly work on that. So if I call the fetch1 function again without running a new query, then it is going to return the second result, and then each time I call the fetch1 function, it is going to give me the next result. So for example, in here we are showing different information about these users. If we come back to here, so the second user is called Paula and the third user is called Brandon, for example, in this case. We can also get these elements into a Python list. So for example, let's say I would like to gather all the names of the users. I don't really want to print them. I just want to have a list of the names. And in some cases, we can also do calculations on the implementation side. So for example, normally we have the database on some server, and through the network we can have some queries from the individual's computers. We can run queries on the database that's in the server and get the results and show the results on user's computer. With some queries we can do calculations, right? We can find the average payment, etc. But if the calculations are too heavy, maybe we don't want to put so much weight onto the server. In some cases, if it is easier to get the data to the user's computer and do the calculation on user's computer, we might, for example, do those calculations using Python. So in this example, we are going to calculate the average payment for user, which is not a hard task for the server. So with a SQL query, we can easily find the average and just send the average to the user. But in some cases, if the calculations are hard to do, we can prefer to do it on users' computers so that we do not put so much weight on the server. So in this case, we are going to get all the users. Again, actually getting all the users is not that easy in terms of the network. So from that connection, we are going to gather and send all these data to the user. And the calculation that we are doing on user side is actually very simple. The server could do this very easily. In this case, this is not really a meaningful example, but this is just for the sake of example. So we might have very heavy calculations for each of the users. In that case, maybe this could be more meaningful. But in here, we are doing it for finding the average payment. So we execute this query. In this query, we get all the users and we project the name and credit from that user table. And for each row in this query, so this row is similar to this R. So what we get with fetch1 is going to be similar to what we get when we use an iterator. So in here, the first index is going to be what we project in the first column, which is the name. So I initialize a list, an empty list for usernames, and I'm appending these names to this list. And at the same time, so this is for gathering the names, and at the same time I'm also calculating the average. So I'm adding up the credits, so I get the credit amount from index number 1. I add it to the total, which was initialized to 0, and I also increment the user count. I can find the number of users with a query as well, but I'm this time finding this information while iterating from this result set. And once our for loop is done, we calculate the average by dividing the total to the user count. And then we give some information to the output. We write the user count, we also write the total amount of credits, and then we also print the average. But if we look at the output, since these are numbers, when we divide them, it's going to be a floating point number. So we have lots of digits after the point, and sometimes you may want to put it in a better form. There are actually lots of different ways to format numbers in Python, and one way is to use this convention. So as a string, I write the format text. So this means before the point there could be any number of digits, but after the point there are going to be three digits to indicate the decimal places. And then we use this format function and give our average variable to that function to format the text in a better way. So for example, in this case, this is how it looks when we format it. And then remember, we gathered all the names. We can just print that list using the print function. And in some other task, maybe we can use that list for different things. And in this case, this is the list of all the names in our database. So for this last example, we are going to do some filtering or searching. So in most of the functional requirements, there are similar tasks. For example, you may need to filter the products according to the name of that product. In those cases, you may need to do some text searches. And remember, we are able to use regular expressions. So with a regular expression, I am able to use this percentage sign to say that any number of any characters could replace this symbol, or I can also use this underscores, meaning that any character, but one character should replace this underscores. For example, if I were searching for names with 3 letters in it, I can put 3 underscores. So in here, we would like to get some substring from the user, and using that substring, we would like to look for the names and surnames of the users. And I want to have this substring within the name or within the surname. So that's what we are doing. We get this input from user. We say, okay, give us a substring that you are searching for in the name or the surname. And we append this percentage symbols after and before our inputs. So for example, user is going to write something like AB there, and we would like to append this symbols just before and end of the string. So this is what we are doing. We concatenate the string using this plus symbol to the input that we get from the user, and we would like to actually display the filter results. But while displaying the results, for example, for each user we have the ID, and this ID could be the social security number as well. And while listing all the users, maybe we don't want to display their social security numbers. In most cases, when we are listing some values, we would like to have some indexing for each of these rows. So in this case, instead of using the ID of the users, for example, we can index the users with a different variable. So first, what we do is to execute this query. So let's look at that query first. So that's saying, okay, select ID, name and surname from the user table. and I have a condition for name to be like this question mark or the surname to be like this question mark, and those question marks will be replaced by our partial text. So I'm passing a tuple to this function. So this is my tuple, and to replace the first and the second question marks, I'm using the same string, and that string is called partial text. It is this string. We get the input from the user, and we just concatenate the percentage signs. And then for this users list, I just append the rows, individual rows. So I could have also collected the users through the rows, but then I need to like specify the individual indexes, etc. I can also for each item in this list, I can have a tuple, or I can have a list of values. So in this case, in the users list, in each row, I have a list of elements. After we execute this query, maybe there is no such user, and in that case we are going to fail this condition. So in here, my condition is for the list of users to be greater than 0. If we fail that condition, we are going to print no such user. Then if we found some users, then I am going to print we found these users and initialize some indexing starting from 1. And while printing all the users, so I iterate over the users list, so I call each element a user, and while iterating I print the index and I increment the index by 1, and for each of these I print this user's name and surname. So remember, name and surname are in index 1 and 2, and I put some tab character in between. And then we ask to the user to choose one of the existing users in the list. So we say choose one user to show more information. So let me actually run it to show it first. So first I need to enter a substring I'm looking for. Let me write O, for example, in this case. So these are the users that contain a letter O either in their name or in their surname. And we are not displaying the IDs of these users, and we are given an option to choose one user to show more information. For example, let's choose Marta. So I'm going to write 3. And for Marta, we are displaying the whole information. So in this indexing, Marta is in position 3. We chose Marta using 3. But actually, Marta's ID is different than 3. So Marta's ID was 5. Then we run some other query to display the partner companies of Marta, for example, here. So let me go back to the code. In here, we display some indexing for the user. Then user chooses one of the list elements. Then we need to map this value for chosen to the list item. So remember, in here, we start from 1. Therefore, I need to decrease it by 1 to have the indexing that is defined for the users list. So I displayed all the items from the users list, but while displaying, I started indexing from 1. So I iterated using this for loop, but I have some other indexing here to have those numbers. Then the user is going to choose among those numbers, and that chosen index should be larger than or equal to 1, and at the same time it should be less than or equal to index. So this index was initialized to 1. While printing each element, I incremented by 1. So at the end, this is going to be equal to the last number that I have for a user. And to find the user from the users list, I need to decrement chosen. And then if I would like to get the ID of this user, it was in index 0. Remember, in here we selected the ID, and that's in the ID index 0. Then if I am interested in the ID of this user, so in this case, for example, we chose Marta, and Marta's ID was 5. So in this case, user ID will be 5. And then we execute another query to get all information. For example, we could have lots of different columns in the user table. To do this task, we only got the ID, name, and surname. And then to give more information about this user, we run another query. But this time our condition is saying that the ID should be equal to this user's ID, the selected user's ID. So this is different from the chosen variable, but there is some mapping through this users list to the ID of that user, and we are using the ID of that user to get more information. In here we know that for this ID there is only going to be one result, so therefore we just use the fetch one function. We got the row, we printed the row, and then with some other query we can also print the partner companies of this user. So to do that we use this query. We are selecting the CID, company name, and monthly payments, this time from multiple tables, so from partner of table and the company table. And our condition, so first to join these two tables, the company ID in the partner of table should be equal to the CID of the company table, and the second condition is for the user's ID to be equal to this user ID, and that user ID is the one that we just selected. And for this chosen range, if the user chose some value that's not displayed on the list, then we are just printing out of range, and at the end we are just closing the connection. So let's try to run it again. So the substring that we are looking, for example, maybe OE, so there is only Joe Bell with this information. So if I choose 5, for example, it's going to display out of range message. But since we are not using any while loops here, then it's going to not ask for any other input. So we could like include some while loop to make it continue. So maybe AR. So these people have AR in their name or surname. For example, Clark has it in the surname, Marta has it in the name. And in here again we are able to choose one of the users, and for example for this user there was just one partner company. And for example if I run it again, for example the new user Marinette, if I choose that one, there is no partner company, so we are not displaying anything there. So maybe in this for loop as well, after we execute this query, if we do not have any values, we can just print this user does not have any companies, for example. That's also one possibility. But other than that, that's going to be it for this lab. So I guess it would be a good thing to like try to run this code on your computers. So I just said that the Jupyter notebook is there. If Python is not installed on your computer, then we suggest using Anaconda Python distribution because it's easier to install. But otherwise, if you prefer to use some other distribution, that's also okay, as long as you install some version of Python to your computers. And in the examples, we are using the Jupyter notebooks because for the labs, it's easier to manage. You might just also include the you might not use Jupyter notebook, so it's not required. You can use Spider, for example. Then there is also the .py versions of the code that we include on the website. So to generate such code, we are using so let me go back to the Jupyter notebook. So in this notebook file, we can download it as different versions. So when we download it as a Python extension file, then what we have is all the cells together within the same page. and you may need to comment out some parts of the code. So let me actually do it like this. So when you open it, this is going to be including all the cells together in just one text file. So for example, if you try to run this whole file, it might give you errors because this is not designed to run it as a whole. So you need to get some specific parts. For example, this is in cell 1, so it also includes those markup cells to give the information. This is one of the cells. For example, if I would like to run it, I need to separate this part from the rest so that it makes more sense if you are using the Python versions of the codes. And one other thing, while you are working on these examples, you can also consider the functional requirements for the project, because at the end you are going to use Python to implement these tasks. For example, you list a bunch of values, you give some text boxes to the user writes something to those text boxes, and with a button you can insert data to the tables, you can update values. For example, maybe we choose one user from a list of users, then what we need is the ID of that user. And in the next lab we are going to look at graphical user interfaces to supply such functionality. But the thing about the SQL3 library is included in this lab. So with the things that we have seen, we can do any of the functional requirements. So these are sufficient for interacting with the database. And in the next lab, we are going to look at the graphical user interface elements, so buttons, for example, text boxes, etc., to have better interaction with the user. So if you have any questions you might ask, other than that, that's it for this lab. So if you don't have any questions, then see you later.